Hi, so in this section we're going to study polymorphism. So what is polymorphism? Well, basically it's the ability to define a generic type of behavior that will potentially behave differently when it's used with different types, with different object types. And Python is very polymorphic in nature. It has what we call duck typing, which is really just an expression that was coined, which is that if it walks like a duck and quacks like a duck, then it is a duck. If you think about this sentence, what it means that as long as an object has certain behaviors, we can use the behaviors of that object without caring what the object actually is. And we've seen that in Python a lot. For example, when we iterate over a collection, the object just needs to support the iterable protocol. It doesn't matter if it's a list or a tuple or a dictionary or a generator or even our own custom class, as long as it implements this iterable protocol. That's the only thing we care about. So then we can call iter. Now iter needs then to return an object that supports the iterator protocol. And that's, again, all we care about. We don't care what that object's type actually is. As long as it supports the iterator protocol, we can use it. So other operators as well in Python are polymorphic, like the plus, the addition, subtraction, multiplication, division. They're all polymorphic because they really work with different types of operands, with integers and floats and decimals and complex numbers, right? Even lists and tuples we've seen. We have addition, we have multiplication by an integer, for example. And our own custom objects, of course, we can also implement those operators. We can support those operators by using these special methods like the dunder-add method. And then we'll come back to polymorphism in the context of inheritance, but we'll come back to that later when we actually look at inheritance. So special methods. We can add support in our classes for many of Python's functionality using these special methods. They start and end with a double underscore. So very often people call them dunder methods for double underscore methods. Now, one thing I want to caution you about. Never use this naming standard for your own methods or attributes. I often see people using that in their code, and that's not a good idea because really, Python lets you do this, but really those dunder methods are kind of reserved for Python itself because that's how it implements a lot of its functionality. So right now, you may pick a dunder method or a dunder symbol that works, that doesn't clash with what Python has, but there's no guarantee it won't in the future, and then your code will break. So it's a bad idea. The other thing too is that in general, as developers, when we see these dunder symbols, we kind of recognize them as being Python's things, right? Not custom code. And so it makes it more difficult to read the code or understand what's going on necessarily. So again, don't use dunder method symbols yourselves. There's no point, right? You can certainly use this. You can say dunder myfunc dunder and define it to be equal to something, but there's no need for it, right? You can use a single underscore or you can use no underscores or do something else. Just call it something else. So special methods, we've already seen a lot of them throughout this series. For example, the dunder init, as we saw earlier in this course, is used during the class instantiation. Now we also have, for example, the dunder enter and dunder exit methods. Those are used for context managers. Now we also have the dunder get item, dunder set item, dunder delete item, and again, those are for implementing sequence types, for example. We also have the dunder iter and the dunder next. That's for implementing iterables and iterators. Then we have the dunder len method, for example. That's for implementing the len function that Python has. We also have, for example, the dunder contains method. We can use that to implement the in operator. So we can use all these special methods in our own classes to provide functionality that Python can then use. And then it doesn't really care about the type, right? It's this duck typing concept. It just cares that do you have a dunder get item, dunder set item, dunder delete item defined on this object? If you do, then all of a sudden you can start supporting various sequence type functionality. Same thing with context managers. As long as you have this dunder enter, dunder exit, you can now start using things as context managers, no matter what type of class they actually are. So in this section, we're going to study a few more of these special methods. A lot of these I've covered throughout this course series, and here we'll just study a few more and see how they work. So thanks for watching, and let's dig in.